Hi everyone, welcome back to my YouTube channel, Chemistry with Sumitpramar. In this video, we are going to solve next 5 questions from the same past paper, year 2018, October-November series, paper code 970111. Let's start with question number 16. Which row correctly describes the properties of the halogens as group 17 is descended from chlorine to iodine? First column is for volatility. Volatility means tendency to get vaporized easily. If I go down the group from chlorine to bromine and then iodine, you can see that the number of electrons increases, hence id forces becomes stronger, and that is why you will see that their physical state also changes. Chlorine is a gas, bromine is a liquid, and iodine is a solid. Hence we can see that it becomes less volatile, hence volatility decreases down the group. Let's talk about strength as oxidizing agent. Oxidizing agent means the tendency to take electron, right? Because it has to oxidize other species, means take electrons from other species so that it can oxidize them. Since chlorine has smaller size, it has higher tendency to take electron. If you go down the group, the size increases. As a result, the tendency to take electron decreases. Hence, strength as oxidizing agent also decreases. Hence, option. Question number 17. Reaction 1. Chlorine reacts with cold aqueous sodium hydroxide to form solution Z. As we know that chlorine reacts with cold aqueous sodium hydroxide and gets oxidized to Cl plus 1 oxidation state. Cl2 is oxidized to Cl plus 1 oxidation state, and it forms ClO minus ion. If you calculate the oxidation state of chlorine here, it will be plus 1. Second statement is solution Z, that means ClO minus, when it is heated, it forms ClO3 minus and Cl minus ion. I can see that option D is the correct response. Question number 18. Which statement explains the observation that magnesium hydroxide dissolves in aqueous ammonium chloride but not in aqueous sodium chloride? Magnesium hydroxide, formula MgOH whole twice. It has low solubility in water. That means it dissociates partially Mg2 plus 2OH minus. When you dissolve magnesium hydroxide into ammonium chloride, NH4Cl, which is a completely soluble salt, NH4Cl dissociates into NH4 plus and Cl minus. This NH4 plus acts as an acid, and it can react with OH minus ion which is present in the solution. It reacts with OH minus ion, and it can give away its proton to OH minus ion to form NH3 ammonia plus water. Hence, slowly the OH minus ion concentration will reduce, and this equilibrium will shift towards this side. Hence, more and more magnesium hydroxide ion will be dissolved. Hence, it increases the solubility of magnesium hydroxide. But if we dissolve magnesium hydroxide into NaCl, the NaCl dissociates into Na plus and Cl minus ion. Na plus is sodium is more reactive than magnesium. Magnesium is unable to displace sodium from the salt, and there is no reaction that takes place. Even if Na plus can react with OH minus ion, that is also highly soluble. NaOH is also very highly soluble, hence it does not reduces the concentration of OH minus ion, and magnesium hydroxide remains insoluble in NaCl solution. Hence, we can see that D is the correct option, because NH4 plus ion can donate a proton, which makes magnesium hydroxide more soluble in. Question number 19. Transition elements and their compounds are widely used as catalysts. What is the identity and what is the oxidation number of the element present in the catalyst used in the contact process? In contact process, vanadium pentoxide is used, V2O5. Vanadium pentoxide is used. If I calculate the oxidation number of vanadium here, it is plus 5. Hence option D is the correct response. Question number 20. What is true for every nucleophile? We know that nucleophiles are electron-rich species. That means they have a lone pair of electron which can be donated. Hence option B is the correct response. Thank you for watching my video. Please like, share and subscribe to my channel Chemistry with Sumit Pramar.